Hey y'all, it's Andrew Couch here, and in this Tidy Tuesday video, we're going to be finishing up my RShiny series with some dashboard optimization. So when we're creating our dashboards, I've kind of gone through like different ways to create them, different ways to develop them with like modules, how to add things into it, how to do basic filtering. But one of the things we have to think about after we create like a minimal viable product is how can we improve the actual operation of the dashboard? So this is one of the dashboards I created in my previous videos. It's just a simple UFC dashboard where we can like change the weight class, um, so we can do like heavyweight class. We can see kind of like a time series of all the fighters and their elo with all the top fighters from that weight class. See a little table of the top ranked fighters of all time. We also have the distribution of the elo scores, and we can change it with this K slider, which adjusts the sensitivity of a of the elo formula. Additionally, we have a head-to-head model, which uses the elo scores to estimate the probability of each fighter winning. So we can do that. Change the elo model's parameters. Also change the weight class to like heavyweight, and that'll filter out all the available fighters in that class. Stuff like that. Um, and it's a pretty cool dashboard. When I created it, I thought it was pretty interesting. It was a good way to highlight different techniques. We have our filtering. We have like a little model into it. We have some cool little visuals. We have some interactive filtering too, with some UI outputs and stuff like that. But if we actually kind of think about and look at the actual dashboard, it's a pretty rough dashboard. There's a lot of ideas that I didn't really think about specifically with the actual speed and render configurations. So if we actually look at this, we can see that there's a lot of um, reuse stuff. So I use the create elo data a lot, where it's a function that uses my existing data frame to run this elo model, combine all the elo stuff, and then output an actual data frame. And if you think about it, when we're switching all the tabs and stuff, it's gonna be constantly running that function. And with this data set, because it's not very large, I think it's like a 2,000 row data set, it doesn't really matter. But when you're working with like databases with terabytes of data, thousands of users or hundreds of analysts looking at it, you can see how we want to make it faster and more efficient, so that way it doesn't crash or cause any issues, and that way we can actually improve the user's experience. Because if it's a laggy dashboard, no one's going to use it, and that's really bad, especially if we spend a lot of time creating it. It's kind of a waste of time for all of us. So right now, I'm just going to kind of go through this and kind of explain what we can do to make this dashboard a little bit more faster, and just some simple concepts that we can do to speed it up. So first, one of the biggest problems we can think about is we don't want to always call this function, right? So we don't want to constantly create a new data frame, run this elo model, and then combine all the outputs from it, right? And if we think about it from just like our use case for this dashboard, we're essentially creating this elo data whenever we change our k parameter for the elo model, which is like the sensitivity criteria. And one of the things that we should always think about is when we're running this type of dashboard, or just dashboards in general, or even model pipelines, is that we really want to do all of the computational work beforehand, right? So we can kind of like pre-run it, or kind of like preheat essentially on this data. It'll make it faster, so we don't have to do so many transformations to it. So right here, since we're doing this function right here, is essentially creating our elo data for a given k value. What we can do is actually just kind of pre-run this data. So in this example, I just loaded in our data frames. I loaded in the function I wrote, and then what I essentially did was I chose some k values that would be most useful for a real application, and then just ran the function to generate a data set for all 5 of these k values, and and then I export it out. So if we look at our elo data, we can see it's essentially the same thing, but we have this little K column, which will show us all of our K values for, or which will basically correspond towards that model's results. So you can kind of think of it as like a nested data frame, but it's just flattened out. And in that case, it's pretty nice. So right there makes it so we did a lot of this pre-rendered work beforehand, and that way it'll make our thing a little bit faster. So right there, it'll speed up our stuff. A few things we should also consider is that when we run this app again, let's run it. We kind of have to think about, what are people going to be doing for our dashboard, or how are users going to be interacting with these filters? So for example, this K slider, it's in scales of 1, and realistically, we're not going to think that, hey, changing a K value from 40 to 41, it's not going to do a lot, right? So instead of allowing the user to be able to do all this complex stuff, we want to kind of like simplify the experience and simplify the usage. So that way we have like less complications. So what we can look at is maybe thinking about changing, and the slider input from 1 to 100 and a value of 20. We can kind of specify essentially like the increments of it. So if we do that, we know that the Shiny has the slider input. And what we can do is basically adjust the step to match essentially a larger increment value. So that way they're essentially like kind of like in increments of like 20. So that way it's a little bit easier and it makes more sense for the user because, we don't really need that granularity in the actual dashboard. Okay. So we don't need to save that. So we can run this again and we can kind of go over here. Right. And we can also look at this, how, again, if you look on my previous video about, reactive variables, I didn't do it for this model. And in this case, an ELO model is extremely fast. It's essentially like a linear time model, right? Because it's just assessing the two scores with the formula. You don't even have to run it as an ELO model. You can just calculate the formula by hand in R, which is vectorized. So in this case, it's super fast, right? You can do it essentially in real-time predictions. But, if we're running maybe, like an SVM model, we might not want the model to be called every time we just move this slider. Instead, we would want a button to say like, okay, we're going to adjust this parameter. We're going to choose these fighters. We're going to choose these weight classes or whatever. And then we're going to run the model to get the actual probability. Okay. So that's also an idea that we can do. Additionally, what we can think about is how we can look at these plots. I'm sorry, I don't know why I'm always doing that. So when we're creating a bunch of these plots, we also have to think about, how many plots actually need some type of filtering, right? Not every plot needs a crazy specific filter. Even though when you think about it, like, oh, hey, we're filtering data, that means it'll be easier for the model for the plots to render out. But adding all these filterings towards every plot by just like changing one thing. So if we just change it to like flyweight, it's going to change all these things. We kind of have to think about like how useful are these global filters for our dashboard. We might want to consider, some charts where we don't need a filter on it. Obviously for this use case, I think it's pretty useful to see the filtering, but maybe for weight class, it might not be as necessary, right? Just to view the distributions of it or whatever. Also for the table, it'd be necessary, and maybe even the time series, it might be necessary. But just these considerations of essentially simplifying the dashboard will be better for the actual render times for your dashboard development. Additionally, just thinking about dashboards as an actual product that end users will be obviously utilizing. You kind of want to direct them towards how to use it and kind of reduce the amount of complexity to the actual dashboard. Okay, so this is the slow app or the old app that I have, and then I basically created a fast app, and I'm gonna actually kind of go over some things that I changed with it. So one, we have this pre-rendered ELO data that has all of the ELO model runs for each increment. I also have the steps for that. And additionally, what I also have is, since we're always kind of using the same, um, since right here we're using the same data set, right? Create elo data, create elo data. We're calling the same data. Instead of doing that, we can kind of put this into a reactive variable, do the filtering, and then just call this thing. So that way we have one, a pre-computed data set. Two, it's kind of like stored as a global variable. So when it's already filtered, we don't even have to filter it again when we're calling it. And lastly, we can actually do some caching. So caching is probably like the last thing I think you should consider doing because it can drastically improve your actual performance of your dashboard. So when you're caching it, you're essentially saving that in memory. So it's saying like, okay, this ELO data is from these type of inputs. So for reactive stuff, you have to say bind event and then pass in whatever thing that you're filtering off of. Since this is a reactive variable, we do bind event. And since we're also filtering using these two filter variables, so our K variable and our weight class variable, it'll essentially save that kind of data in its memory and kind of recall it as is. Again, I'm doing the same thing for the second pages thing. I also have a event reactive. So let's run this fast app and see this. So in this case, we have a predict button. So we can click that. We can change the weight class and stuff. So we can do like, I don't know, women's bantamweight. We can choose these fighters, choose the specific elo, right, and then predict it, stuff like that. So right there, we can actually switch this model out. Instead of just like a generic elo model, we could switch it to like an SVM, a nearest neighbor model, or something like that. So with bind event, we can basically save those results in memory, and it can kind of recall the actual dashboard can recall it. So with these like weight selectors, I didn't think it's really necessary to do that. But when we go to our actual plot, so right here we have bind cache. So instead of using the reactive variables, and we're actually explicitly using these render plot objects, we should be using bind cache instead. So with bind cache, again, we're still saving the weight class and K value. So that way it'll say like, hey, we used this weight class with this K value for this plot. So if we go back to that K value and weight class, it'll essentially just take it from memory instead of re-rendering out the plot. So you can see it can get much faster. Okay. One other thing that we should also think about, and something that I, especially when I do these type of videos, when I'm doing like live RShiny development, is that you should also consider using base R functions, right? So in this case, right, we have let me find here. We have this thing where it's like, it's selecting the fighter, doing the distinct and the arrange, and then the choices is the fighter selected, the actual fighters that are in that weight class. But we can also do it as a base R function right here. So it's just calling ELO data. I'm using the actual explicit like row level index using the which function and saying which fighter in this data set is equal to V fighter, and then is not equal to V fighter. So we're trying to take out the fighter from there, and then it selects the actual fighter as a list. We unique it out, so we remove a lot of duplicates, and then we sort it. So this is probably a little bit faster than this, but one of the issues we also have to think about is like code readability and stuff like that. So maybe we might even put this into a little function and just say like filter fighter, stuff like that. But that's kind of one of the problems with R in general, is that the code isn't as readable as other languages, specifically like Python. But you should also consider using base R functions whenever you can. That being said, there are some weird quirks with base R and the tidyverse. How, when you're using for loops versus, mapping functions, I believe like mapping functions are actually slightly faster than a for loop in most cases. So you never know, but if you really need to, test some type of function out, consider using base R functions if you have the chance. Okay. So let's actually go and look at this app. And we can see here, we have this. We have the increments. So it'll filter that out. It'll filter that out. And as you can see, it's a little bit faster because it can do that. But as you can see, once we do that, once we kind of already ran these filters, right, it'll just be pretty much like instantaneous, right? So that's a cool way to do it. Again, head to head, we have the weight class. I guess predict that. If we can go there, predict that, right? Um, so again, it's almost once you have someone really using it, it'll get faster because it'll kind of store it in memory. Um, so you also might be like asking like, hey, if I have so many users working on this and I'm like caching all these plots and reactive variables, what about like memory issues? That is a problem, and it's something where it's definitely on a use case where there are ways to basically manage the cache memory and limit it. Additionally, you can kind of like go through it and save the actual cache files and upload it. So that way it'll have like honestly like a pre-rendered out pre-loaded like plots and stuff like that. So I know this video was actually really quick. This is only like a 16-minute video, but these are just some very quick ways to improve your dashboard speed without going into anything crazy. There are some packages, so Shiny, where you can do the um what's it called? The let me pull it up. Shiny dashboard. Um where we can actually look at um ways to basically make it faster by essentially simulations. So let me find this. Where with right here. So the where is it? Profiling, where's the what's the actual package name? Use caching memoirs. But there are ways where we can basically pull up the actual RShiny stuff. Let me find it. Just RShiny shiny shiny right here. Okay, let's see. Shiny dashboard. Let's feed package. Where is it? Let's see. Oops. Well, I guess I can't really find it right now, but there are different packages too that can make it a little bit faster. Um, I wanna find it. What are the maybe it's from here. Oh, actually, how do I package? Oh wait, I have the package. Just packages and then shiny load test. So we can also look at shiny load test. That's what it's called. And the reason why I didn't want to go over shiny load test is it requires a few installations that I think is a little bit too out of the scope of beginner dashboarding. But if you're trying to do actual like production level shiny dashboards, this is a good way to basically analyze what are your bottlenecks for all of your dashboard, all the things that are in the back end for your dashboard. So you can actually like install essentially the the shiny load test package, but you're also gonna have to install this Java file and run it through there. But after you have all that stuff installed, you can basically run a command line function that will basically kind of go through your dashboard and figure out where it's really slow at. And that's a good way to basically identify the things that you want to work on and fix so you can make your dashboards a little bit faster. Okay. So with that being said, that's the conclusion of this Shiny series. I have a few more videos that I want to basically record, specifically on the grammar of graphics. I also want to do a short video on just RStudio's functionality and project development and workflows. So I'm pretty excited to do those videos. And I'll see you guys next time. So tidy on.